Welcome back, everyone. So this is a bit of a continuation on my last couple of videos. I've been doing some wiring upgrades to my mid-50s ranch house, and at this point I would say a good probably 60% to 60 to maybe 75% of the original two-conductor rag wire has been replaced. So when this house was wired originally, it had an ungrounded system. It had maybe 5 or 6 branch circuits, and they served the quadrants of the house. So we have one circuit for the master bedroom, which serves the bathroom. We had one circuit that served the living room and the light fixtures, obviously. A third circuit was the kitchen and garage minus the refrigerator. A fourth circuit ran the refrigerator and the closet lights in the middle of the house and one outlet in the dining area. A fifth circuit, are we up to 4, 5 or 6? I think a fifth circuit served the second bedroom and the basement lights, or that's basically how it broke up. Today, I've made a lot of changes to that, the branch circuits. So I have, in addition to those, we have 6 or 7 circuits, 6 circuits. I have a 7th circuit that serves only the garage, an 8th circuit that serves only the breezeway, a 9th circuit serves the microwave oven and one kitchen outlet. A 9th circuit is for the basement outlets. I mounted them up in the rafters here. Circuit number 10 is the dishwasher and garbage disposal. Circuit 11 is the washing machine outlet only. Circuit 12 is that second bedroom. Now that was actually there when I bought the house. And I think there's a 13th circuit. Oh, the 13th circuit is the furnace, which was always on its own. So there was originally about 6 or 7. So we've expanded the system a little bit. And in all the new stuff I've put in has been, well, in some cases I went with 20 amp wiring. That's 12 gauge. That is a 20 amp. The microwave is a 20 amp. The garbage disposal dishwasher is a 20 amp line. The garage is a 20 amp line. And yeah, so we're beefing up a few key areas of the original electrical system by adding to it. Now this house has already had a panel replacement. It was done in 1983. This house was originally served by what I believe to be a 60 amp panel that would have gone on that piece of wood right there. And according to the building records, this panel was put in back in 83. And I was able to confirm that. I had to pull out 1, 2, 3, 4, 5, 6, 7 breakers. 7 breakers I had to pull out because they were the wrong size. Now, that matters. It really does. In the case of breakers, size really does matter because this house was wired with 14 gauge wiring. In fact, all the branch circuits in the bedrooms and even the kitchen are all rated for 14. They're all 14 gauge wiring, which automatically rates it at a maximum of 15 amps. And the cowboy jockey who put this breaker panel in decided, well, hell, you're just going to blow breakers if you put a 15 amp breaker in that slot, so I'm going to go ahead and put in 20 amp breakers. Don't do this. Do not do this. This is dangerous. This is how fires happen. Now, for nearly 40 years, the house has been running on oversized breakers, and nothing seems to have happened. I've replaced every fixture, light switch, and outlet in this entire building, and I have found no signs of any overheating wires of any kind. So the good news is nobody overloaded anything in that time period. But if somebody came into this house, maybe either an owner or a renter, and started plugging in space heaters, that could be a very different end result. The maximum wattage of a 15 amp circuit is, believe it or not, really not that high, about 1800 watts. It's measured volts times amps equals wattage. So, 20 times, or no, 15 times 120 is 1800 watts. So if you were running a couple of hot plates in the kitchen, just 2 hot plates, you've already exceeded the ampacity of that circuit. Which is why kitchens are supposed to be wired a little bit differently. You're supposed to have, as far as I know, I believe every countertop outlet has to have its own 20 amp breaker. And therein you see the problem. I have a loaded panel. I can't add any more. So I am postponing rewiring my kitchen because I am out of space. And I don't want to use duplex outlets. These I don't like these. I don't. They're not coded for new construction for sure, but they're okay. I guess they're okay for retrofitting an old panel, but I'm not doing that. I'm gonna wait until I have the money for a new panel and have it professionally installed. But getting back to the oversized breaker situation, yeah, clearly nothing horrible has happened to this point, but overloading panels or overloading circuits with larger breakers is exactly why it's one of the main reasons why fuse boxes are practically uninsurable. Because if you have a house wired with a fuse panel, what can happen is if you start blowing 15 amp fuses because your air conditioner is running on the same circuit as your refrigerator, which is obviously overloading the circuit, you're going to keep popping breakers. So what people used to do in the old days is they would take that 15 amp fuse out and put in a 20 amp fuse or a 30 amp fuse. And the sad thing is they shared the same exact socket size. And if you were really especially stupid, you would put a penny behind the fuse panel. So it was far too easy for homeowners to overload their circuits with overrated fuses, thus causing house fires due to overheated wiring. I mean, this breaker is your first line of defense. And if this thing fails, the only other breaker that could pop is your main breaker. And that's only going to pop if you exceed the 100 amp rating. By that point, your house is already on fire. So, I mean, if we were to take a hot and neutral and just bond them together right now, it would take a little bit for this guy to blow. That wire is going to get glowing hot, and then it's going to maybe blow. I don't know how many amps it'll draw, but it should, if it's a dead short, blow the main breaker, but chances are it won't without causing a fire first. So you don't want overloaded breakers in your home. You just don't do it. So fortunately, these old Square D QO breakers are very easy to get, and they're not expensive. I think one breaker is like, I don't know. I think I paid $7 or $8 per breaker. That's not too bad. But here's what really scares me. This panel was installed in '83, and they did in fact pull a building permit, or a permit to install this panel, as you should. But what they didn't do is, if they inspected it, if the city inspected this panel, whoever did the job should be fired. And I hope he's no longer working for the city, because it should have failed immediately, because it was overloaded with 20 amp breakers. Every slot had a 20 amp breaker in it. Not okay. That's not okay. And there's one other safety issue that I found, and that was, rather than rerun some of these cables, they just put in junction boxes. I think that's fine. That's okay. But they ended up sharing neutrals. Like, for example, this box right here, it has 4 wires going out and 1 wire going in. Each one of those wires should be its own circuit. Each one of them. But they're not. No. Instead, they've got 2 circuits, 1 junction box. And one of those circuits is a 20 amp circuit. They pigtailed it using a 14.3. That's 14 gauge. That's 15 amps max. Through 14.3, that's this wire right here. There's 2 hots, 1 neutral. So we're sharing a neutral between those 4 wires. They're sharing 1 undersized neutral for that 1 legitimately 20 amp circuit right there. That black wire, that's a 20 amp right there. That's a 12 gauge wire. And it's just like, how did this pass inspection? I have to wonder about that. And there was plenty of room in this panel to do the job right, but they chose not to. They chose to take the easy way out and just call it good. I think in 1983, maybe that was okay. Maybe that was okay. Shared neutrals between a 20 amp and a 15 amp circuit. Whatever. I'm not even going to touch it, because once I do, I own it. So if something happens, it's my fault. But what I would do immediately to rectify this is I would probably have to add a couple of duplex breakers. But as you can see, my neutral bus is completely full. My ground bus is completely full. Not okay. So clearly we've outgrown this panel. As I've rewired things, I've tried to modernize by adding extra circuits, and that's why we're out of, so I'm trying to do things to the current code, and I'm dealing with, So as I was saying, I've started rewiring portions of this house by ripping out the old ungrounded rag wire and putting in nice brand new Romex. So the circuits that I've completely done so far are the garage, the breezeway. Now the garage, as I said earlier, was part of the kitchen. It is now divorced from the kitchen. It is now its own thing, as is the breezeway. Both areas were off the kitchen, and it was built that way. That was not a later addition. I have completely rewired the living room, the master bedroom, and the bathroom. And fortunately for me, none of the wire was stapled in the walls. So thank God for that. So I'm able to just pull the wire. It's like running needle through a thread. Wait, vice versa. Running thread through a needle. And the right thing would have been, in my case, to upgrade the wiring to 20 amp. I think that would have been a smart move, but this was a massive cost savings, and 15 amp is code compliant with the distribution that we have. And honestly, the only thing we run in the bedroom is an air conditioner, a small air conditioner, which I looked up what it draws for wattage on startup and run, and it's fine, totally fine. But once again, we come back to these breakers. I had to replace these. Morally and ethically, these had to be ripped out. Now, I did one thing a little different, a little pricey. But you see this guy right here? This is a modern day arc fault GFCI breaker. This does 3 things. This breaker, it breaks the circuit if there's an overcurrent situation. It'll break the circuit if there's a loose connection somewhere and it arcs. And it'll break the circuit if there is a ground fault issue. Let's say we accidentally drop the toaster in the bathtub. Now, why I went with an arc fault and GFI break. Now, arc fault, by the way, is code required by today's standards. If we rip out this panel and we put a new one in place, every breaker, as far as I know, there may be some exceptions, they have to be arc fault. Now, there's an enormous price difference between these standard breakers and these arc faults. This one breaker cost me around $65. One of these is about $7 to $10. So there's a massive cost issue there. You better not jump up on that panel. I won't kill you, but the Tesla AC current will probably do some damage. Please don't jump. I swear to God, if you do, I'm going to be very sad. What was I saying? So, yeah. So modern day breakers must be arc fault, GFCI. And it may sound like a cash grab or just a lot of nonsense because we've had these for all these years and now all of a sudden they're a problem. Yes, because modern technology has caught up to allow us a breaker that does all these cool things, and it will, in the end, make the system a lot safer. House fires are caused, electrical fires. There are two root causes to them. Overloaded circuits is one big one. An overloaded circuit will, over time, cause the wire to heat up and cause the any framing members, timber, insulation. If you have a house that has combustible insulation, it will cause a house fire if the circuit is overloaded. I think that's something we all knew. But there's a second cause, and that is loose connections. A loose connection can very quickly escalate into a fire because when you have electricity jumping, I mean, when these connections are all good and tight, there's enough surface area between the terminal and the wire to allow free flow of electrons. But when those electrons have to work harder to get from point A to point B, it causes the connection to heat up. And like I said, it can reach ignition temperatures very quickly, especially if there's a heavy draw on that circuit. I'm thinking like an air conditioner, a space heater, appliances that draw a lot of, an air compressor is a good one. Anything that draws a lot of current, a toaster oven, things like that, very quickly can escalate into a fire. But what an arc fault breaker does is it can sense, I'm not exactly sure how they work, but they can sense, I believe, either an intermittent connection or something it's looking for, the power going in versus the power coming back. If there's an imbalance, it will, because as we all know, AC is alternating current. Power flows out one way, comes in another, which is why I can grab this neutral bus and not get electrocuted. But if I grab either of the hot legs, I'll be thrown back into whatever's behind me. So that's, yeah. This is bonded to the earth, to ground, where these two are trying to reach earth, ground. Anyways, so what these breakers do is they give us a little bit of a protection against a ground fault, against an arcing situation where there's a loose connection. Now, one concern I had with an arc fault breaker is, how will my antique appliances handle that? Or will this handle an antique appliance where they have switches that don't snap, they don't close rapidly? For example, my 1923 GE fan. It has an old-fashioned sliding switch, and you can see sparks. It's like one of those bumper cars that they have at the fair where you look up and there's that little pole. It's like got a contact on the end of it, and you watch how it drags across the energized ceiling, and there's sparks everywhere. Well, that's kind of how these switches work. So after I hooked this all up, I went upstairs and I started turning the fan on and off, on and off, on and off, and it did not trip it. So it must be looking for a sustained or I'll have to look that up. Now, as for ground fault, I did mention that it has ground fault as well. That does bring the cost of the breaker up a little bit. But with a ground fault built in, remember, my master bedroom serves the bathroom as well. So what happens, so there's one fixture in the bathroom that I'm concerned about. It is a 1954 vintage lighted mirror vanity cabinet combo thing. And it has, as they often did back then, it has a built-in outlet underneath it, which is directly above the sink. Now, I looked for ways to GFI protect that fixture. And I pretty much came up with mounting a GFI outlet or a GFI. They actually have a GFI, it's like a breaker, but it mounts in a standard outlet box, and it is a ground fault circuit interrupter and nothing else. Mounting it above or below or near that vanity. And that would protect it if I wired it into that device. But I'd be cutting more holes in my walls. And let's be honest, that particular vanity is nobody ever is going to plug anything into it, at least as long as I live here. And I know my girlfriend doesn't use it for her hair dryer. She doesn't use it for her curling iron. Or whatever hair tool she has. Fortunately, there is a circuit in the bathroom. It's actually in the bathroom closet that is a dedicated GFI protected circuit with a GFI outlet in it. And there's a mirror in the back of the door. So when you open the closet door, there's a mirror right there, a full-length mirror, and there's an outlet right in that closet. And that's where she plugs in her curling irons and shit. So, or hair dryer, whatever she uses. So I'm like, and I thought about maybe rerouting the vanity power to the GFI outlet in the closet, but I don't think that would be. Anyway, so I just said to hell with it. For a couple extra bucks, I bought the GFI protected breaker. So, hey, modern day electrics in at least part of the house. Now, I'm not going to go through the expense of replacing all of these breakers right now with arc faults because I don't have a reason to. This is an existing installation. It is an older house. I don't see a reason to do that. But what I did do is I spent 50 bucks or so, 60 bucks on all new 15 amp breakers. To at least give us a little bit of peace of mind, knowing that should there be a serious overload on any of our electrical systems, we are better protected. Now, in the future, I'm going to start shopping around. I'm hoping once we get COVID behind, yeah, right. That's not going to happen. But I do plan on, in the future, having an electrician come in and evaluate what we have, possibly upgrade to a 200 amp panel, and check this out. So this house has two separate meters. For a while, throughout the 60s and 70s, and possibly in the 1950s, I'm not really sure, this particular house, the state of New Hampshire, was doing dual meters on single-family homes if they had electrically heated water, or other resistive heat systems that could be replaced with gas. And the idea was they wanted to encourage people to use electric appliances because they are more efficient than gas or oil. I was just at my girlfriend's aunt's house, and her house was built in '68, and it is one of the only houses I'm aware of in the state of New Hampshire that has electric radiant heat throughout the house. It's just not a thing here. And the reason is, back in the 60s and 70s, you were charged a separate rate, a lower rate, for any heating appliances. It was this whole big push for modern electric heating in your home. So what they were doing was they were giving you separate meters for your water heater, your electric heat, what have you, and charging you a lesser rate. That program has expired. They no longer do that. So there's a lot of houses left over that still have dual meters and two completely separate power feeds coming into the home from the meter box. And the end result is we're basically getting charged the same rate regardless of which meter it's being pulled from. So anyway, short story long, I'm thinking of putting in a larger panel right here, keeping the dual meters, because why not, and putting in a separate, rerouting this breaker into the garage. So what I want to do is put in another 100 amp panel, maybe this one, maybe we reuse this panel. We mount it in the garage, and this would become a sub panel. I don't know how you would change it to a sub, but I think it can be done. But turn this guy into a sub panel off of a main disconnect switch like this one. Maybe put a 100 amp load center or put a 100 amp breaker in here, or whatever it'll take. I don't know how big it can go. And then, you see what I'm doing? So this becomes the disconnect. Here's why. You don't want a feed wire running the entire length of your attic without any means of disconnecting it or any way to protect it should something go wrong. So what I want to do, like I said, I want to move it out into the garage and put this panel out in the garage. This way, in the future, when I am forced to buy an electric car, and I will be forced to, it will not be a willing decision, but that's just the way the world works. I will have plenty of power to charge. I want to do up to 2 cars, provisions for 2 cars, not just one. I mean, what do you think? You know, why not? But yeah, I would have a panel out in the garage wired up as a sub panel, and this would be the perfect one to use if it can be reconfigured as a sub. Sub panels typically don't have a service disconnect inside of them. The service disconnect is at the point of entry coming into the house, as far as I understand it. So right now, all we have is a water heater running off of this guy. That's it, just a water heater. And no, there is no aluminum wire in this home other than the feed wire going to the electric stove, which is original wiring, by the way. I forget what gauge. I think it's 10 gauge, actually. Let's take a look. I can see part of it. I can see the writing on it. Let's see. Here it is. Service entrance cable. This is rated for outdoor use. What is the gauge on that? I can't really read it. Hold on, let me stop my phone and look at it with a flashlight. It says 8.3 grounded, which is interesting. Yeah, it says 8.3. So it could be 8 gauge, I guess. But anyway. So yeah, they've got that 8 gauge aluminum wire, which is commonly used for service entries, which is fine as long as they're used correctly and properly torqued. Now it's going into a breaker that it does say CUAL, that's rated for copper and aluminum. So that is correct. And yeah, for heavier cable, the aluminum is commonly used, even today, I believe. But none of the branch wiring is aluminum. It's all been copper, always has been copper, thank God. That's more of a safety hazard than an oversized breaker, I think. Or used in conjunction with an oversized breaker. It's actually pretty nasty stuff. Anyway, so there's that. But yeah, I want to have this panel replaced, and it's going to cost me some major coin. I just know it. Thousands and thousands of dollars, I'm thinking. probably, yeah, that's the thing is labor is a pretty hot commodity right now, and electricians, and all I can say is I am ever grateful that I went on a house repair marathon for the first 3 years, first 2 to 3 years of owning this house. I was on a house repair marathon, getting as many systems upgraded and replaced and fixed as I could. Exterior work, doors, not replacements, but repairs. Replace the basement windows. I'm doing as much as I can while I can, because again, the price of building materials is going up. I had that furnace done in 2019, I'm sorry, just before COVID hit. And I am ever grateful for that, because I think I would be paying 1.5 times what I paid for it had I waited. So thank God for that. So yeah, owning a home, especially in a time like this, is not fun, especially if you have a house that needs repairs and yeah. But anyway, this is going to be an expensive project. I'm going to have a professional do it. They're going to have to pull the meters. While I do this, there has to be an upgraded ground wire. This house, the ground wire from the box to the ground to the earth is, I believe, 12 gauge bare copper wire. Basically this right here. Just that's it. That's what's grounding the meter box. Now it should be, I think, like 2 gauge. It should be much larger than it is, but sadly it is not. And here's what really kills me. The meters and the feed line coming from the street were replaced in at least 2009, according to the date on the feed wire. And you think they would have done something about that undersized ground? No, they didn't do that. I'm not allowed to open the meter box. There could be fines if I touch the seals on the box. There's 2 seals on the box, and if I touch them, I could be fined by the power company. It could be really ugly. So they told me I have to have a licensed electrician do that. I'm going to probably have that done before I do this, because that is a bigger safety issue. And the reason why is if there's ever a lightning strike, that ground wire will melt before it protects anything. So we want to get a much beefier ground wire to this place if possible. The panel is grounded directly to the water main. As I understand it, that might be okay. But I think in 2021 there are different ways that they ground panels. I'll have to look into that. But it's this ground wire here, and that goes around and snakes over to the water pipe. And in fact, this is it right here, and it's clamped all the way down to where it comes in from the street. Now that's a copper line, not lead or anything weird. It's a copper line going straight down into the to the water main. But I don't think that's legal for a new install. I think it has to be done with a dedicated ground rod. Not really sure about that. But it is grounded before the water meter. So if the water meter and valve are replaced, don't. He's looking at this box because I am, and he's curious. And you know what happens to curiosity and cats? It's really not a fun time. So why don't you go play with your brother or something? Oh, here, go play with that wire. That's fine. Anyway, I should get the box on this, the cover on this box. But anyway, so I just thought I would talk about some of the safety issues I found. Oh, and before I continue, or before I end this video, while I was doing some of my rewiring work, I did find there was one junction box that it's right above the bathroom. It was an original junction box. It's always been there. It's in the attic space, so it's not in an enclosed area. It's where it should be. But that particular junction box, all the wire inside it was crumbling, like every bit of it. Every piece of wire in that box was at risk for becoming a dead short circuit because the vinyl insulation, for whatever reason, now before you say it was overloaded and overheated, there's nothing on that end of the circuit. It's really, there's a light fixture and a fan, and that's it. So there's nothing like that. But what I did notice when I went up there, actually noticed it when I bought the house, but that particular junction box was open, and there was a the bathroom fan was blowing directly into it for at least 40 years, which is kind of terrifying, but that's how they did it. The fan that was installed up there was probably from the 70s. And yeah, they didn't bother venting it anywhere but right above the ceiling. So I wonder if that moisture exposure over the course of so many years might have caused degradation. But nowhere else in the house have I found that. It was the only part of the house where I found like an actual, holy crap, this is going to cause a fire type of situation. But I'm making this video to kind of share some awareness. What are you doing? Of, you know, this could be in your basement and you might not even know it. Yeah, you might not even notice. But, you know, take a look at what kind of wires going into the panel. If the house was wired within the past 25 years, I think, everything is color coded. So yellow is 20 amp, white is 15 amp. And then there's a few colored variances from there. I think black Romex is rated for underground use. Yeah, there's a few different variables. I just noticed I've got this guy here. Where the hell does that go? I don't know. So this wire goes into that box. That's the power source for that. But I've got a black wire going in there as well. I should investigate that, and I'm going to report back. All right, so here's what we got going on. So we've got actually two wires going into this junction. So two completely separate circuits in the same junction box. So there's one circuit, two, three. There's three circuits going into this box, and there's three going out. What they did is they were lazy, and for some reason, yeah, they used the 14.3 to serve three circuits. I'm sorry, two circuits, because 14.3, that's two hots, one neutral. And then they've got this 14.2, which is serving yet another circuit. The wire that I was concerned about actually is for an air conditioner, and it's this guy over here. And I thought that was a 12 gauge because they ran it to so this black wire here goes into the kitchen. There's an outlet underneath the kitchen window, and it is for an air conditioner. And I think I might have found another problem just as I'm shooting this video. But it's an easy one to fix. What I'm going to do is I'm going to downrate, once again, downrate the breaker and bring it down to a 15, which is what it should be. That does look like a 12 gauge wire though. I just can't read it. It's an old-fashioned embossed wire. I just can't read what it says. Can you? No. I see 600 volts. I think I already determined that was a 12 gauge. Interesting. I'm going to try to find a better spot. I see 12.2. 12.2. So that's going to serve, it has been serving as an air conditioner line we hook up I've got a 12,000 BTU AC. Now when you start getting up into that size range of an air conditioner, it should be on a dedicated 20 amp circuit, no less. Looks like that's what they did, but which means that we don't have as dangerous of a situation as I had thought. But here's the problem. Let's see if I can identify the problem. So there's another wire coming out of this box, and it's the same size, indicating that they're feeding that 20 amp monster with a 14 gauge wire. Those cheap bastards. So, like I said, I can't really see the print on it, but it's just about the same diameter. So what they should have done, if they had put 14.3 there, it would have been safer, but they didn't. They put 12 gauge. But it's such a short run that it may not be a big issue right now. It's not great, but it's not a huge problem as it stands. So really what it really comes down to is I have some wiring I got to do in preparation for a new panel, or after the panel is done. I can either go back and fix it, or if the electrician wants to do it at a reasonable price. But you can see how they bored all the holes. All of those wires used to come through here, and they went to a fuse panel right here. You can almost see the outline of where it was. And this still has the original. I would show the permit, but it has my address on it. Here, let me block off some information. That's the original permit for the wiring in the house, which was pulled on 8/24 of 1954. So there was a junction box here, but I took it off. I was able to rerun one of the wires that needed it, so I took that off. It was no longer necessary. When the breaker gets updated, our box that gets updated, I'm going to focus on cleaning this up a little bit. But there will be no junction boxes unless they're absolutely necessary. I think those can go away. Yeah, they won't be necessary after all that gets done. They'll just be obsolete. Because I'm going to pull, my plan is to pull all new wire from the kitchen, the second bedroom, and wherever the hell the other one goes. The refrigerator, I think. We're going to re-pull all that, just as I had done with the other circuits, and we're going to be using whatever appropriate wire size. The kitchen is going to be all 20 amp. That's I think that's a code thing now. So the kitchen alone is going to need about 3 circuits. One for each countertop outlet, and yeah, and maybe even one for the little outlet under the window, or maybe we'll leave that as a 15 amp. 15 amp wire, or 14 gauge wire is a lot cheaper than 12 gauge wire. So yes, there's a cost matters too, but safety trumps cost all day long. So as long as you've got the right rated breakers for the circuits bands. And one thing you want to know is the circuit can only be rated up to the in other words, the weakest link in a chain determines the strength of the entire chain. So you can't have a 20 amp circuit, 20 amp breaker with 12 gauge wire going up to that outlet right there, and then run the rest as 14 gauge. That would be illegal, because anything that overloads on the 14 gauge or 15 amp rated section of that wire won't trip that 20 amp breaker. So if there is anything on that circuit, wiring wise, that can't handle the full 20 amp load, then the circuit has to be downrated to a 15 amp or whatever's below it. And That is an electrical code requirement. The exception being, I believe, light fixtures, because light fixtures typically have 18 gauge wiring, which is much thinner. Wire gauges, the higher the number, the thinner the wire. Yeah, light fixtures typically have only like 18 gauge wire in them, and obviously that's not food, Oreo. That is a zip tie. You cannot eat zip ties. You don't want eating zip ties. Cats will eat anything except human food. I don't know why that is. They won't eat any human food, but they'll eat zip ties. They'll eat string, they'll eat zip ties, they'll eat tinsel, but they won't eat anything I cook. Before we close out the video, I want to show you how to date these breakers. If you look up the date code of square D breakers and equipment, there's a pretty neat code that you can determine how old something is. In the breakers themselves, there's a little label in there with red lettering in this case. Red lettering, it stands out a little bit. It's a little hard to read too. It says FM. This one says LM. This one says UM. Now, the U is the first digit. The first digit is the month. The second is the year. And I determined that M is 1983. Now, they recycle the date codes, actually, every 20 some odd years. So if you know roughly how long ago the panel was put in, we know that's not a 1963 panel, but it is a 1983 panel. So these are all original to the panel. They were put in when that was installed. So we know, based on the date code, chances are that they were overrated upon installation, which makes me question if the inspector even showed up for work that day. But we are here to fix the problems of the past. It reminds me of a meme online. Obviously, most of them are on the internet now. It reminds me of a meme where buying it. What is he eating now? If you buy an older house, he found some insulation that I stripped off. Buying an older house, you're fixing problems that were created 60 plus years ago. The simple act of replacing a light fixture in an older house, you're going to find that the original fixture was likely installed without a box and simply nailed to a rafter without any regard for safety or proper installation. See, houses, they're a can of worms, and the further you dig into that can of worms, the more worms you find. You're going to find plumbing issues, structural issues, stuff that even the building inspector didn't pick up on. The oversized breaker situation, I found that, not him. I actually checked my building inspection report, and that was not mentioned. He did not. And by rights, I mean, building inspectors, they are given so much time for a set fee to inspect a home of this size, and they're not going to pick up on everything. And the breaker issue is not something he found. I did that on my own. But you're going to find, if you buy a house, and it's scary because people today are overpaying by tens of thousands of dollars for houses. They're buying them without really doing their homework, and just got to have a house, so they'll buy it at any price, even if it means borrowing more than they can afford. It's just not a good time to buy a house. But anyway, problems that I'm finding in this house are pretty typical. I mean, there's nothing about this house that I found that would be really worrisome. Just stuff you have to expect when you're buying a relatively untouched but slightly modified house from the mid-1950s. There were no egregious structural issues, just a little bit of water damage over there, and I had to replace some floor joists, but that's neither here nor there. Really what you're going to find in a house like this is You're going to find plumbing issues. You're going to find, and boy howdy, do we have those. You're going to find electrical deficiencies. You're going to find improperly installed fixtures. You're going to find wiring that might be damaged by mice. I found that too. I mean, there's just a lot of things that you're going to find after overpaying for a 1954 ranch house. And boy, have I found them. But slowly but surely, we're getting this place up to what it should be. I think at this point we're at a point now where I don't have to really lose sleep. Everything that could be done has been done. I've even started to go back on some of the earlier repairs I've made and redo them because I've learned a lot. Let me show you one example. So this outlet box, if you look at my older videos, you might remember seeing a piece of plywood that was attached to the concrete wall with ram set nails, and I thought I had to mount my outlet box to that, so I mounted it way up here, not really thinking much of it. But as I was buying the materials, I'd never bought electrical conduit. I've never bought handy boxes. I ended up buying all the wrong shit. You know, I bought a box that was just the wrong size. Not the wrong size, I'm sorry. The knockouts were oversized, so I had to buy a conduit that was like 1 inch in diameter. And it looked stupid. It looked ridiculous. It wasn't on straight. I just did a terrible job. So I went back about a week ago. I tore it all apart. I took the plywood down. I repainted the wall. And I did it correctly this time, making sure to use my wire or my conduit bender to give it a nice standoff, like I did over there. But it looks a lot cleaner. It's better, more cleaner, more stronger. No, it's just a better, cleaner job. And everything that I do that could be inspected or judged good or bad by a building inspector, everything I do has to look clean, and you want to always leave a little bit of a loop at the top. You don't want to tighten it down. You always want to use cable clamps. I mean, this shit matters. I even started taking wire off areas that I've restapled it, or areas that I've added wire. Like this whole section is all me. I went back and I restapled everything. Made it look cleaner, make it look nicer. Thankfully, when I ran this this wire for the washing machine, I actually left a loop on each side of the door frame. I wasn't sure what I was going to do with the door at that time. The door had to be reworked. This whole door frame had to be redone. So I didn't know what that was going to look like. So when I ran that wire, I gave it a little extra in case I had to route it differently. And that really came in handy because I was able to use that extra little bit of wire to pull the outlet down a little more without rerunning the whole run. But stuff like that, you know, little bit at a time, you know. Now this is the this whole beam, I had wire just everywhere. It had wires crisscrossing, and it was just a freaking mess. So I unstapled every wire on this beam, took them all down, and I completely reattached them. I straightened them out, and I attached them pretty fixed intervals using the same type of wire staple. I had 4 different kinds of staples on this beam. Now they're all the same, except for the dryer line, which I left alone. But you see, neaten it up, make it look better, make it look professional. That's the idea. You want it to look good. You want it to look like whoever did the work actually gave a shit. I even put a conduit. I took a PVC pipe. You can't swing a hammer in this space, so I can't staple up in here. But what I can do is buy the biggest piece of conduit I could fit in here, cut a slot on the top, and just attach it to these little pieces of wood right here and run the wire through so that it makes it to the other side. This keeps the wire away from the metal ductwork, keeps it off of the air exchanger over here, or this what's the term for this thing? This, whatever the hell it is. Keeps the wire off all that metal. Comes out the other side, where it branches off to where it needs to go. Make it look better. Make it look clean. Make it look like somebody actually gives a shit. This is all, whatever. This is not me. This was the previous owner. And by the way, there's a date code on this wire from 2002. So label everything you do. Everything should be labeled. So you don't even have to think about it. You know where this goes. You know what that's attached to. I've learned lots. You know, I even took the time. This wire, it had to bend around. I had to bend around. Which one is it? Yeah, this one here. I had to make that bend. So I took the time to flatten the wire out and slowly bend it around and clamp it in that box. Looks custom, but looks matter when it comes to electrical work and plumbing and carpentry, and it's all relevant. Well, anyway, also really wish the builder didn't do this. Did you know that if you notch the top of a floor joist, you don't lose any of the rating or any of the load capacitance? But if you notch the bottom, you can go from a rated 2x8 or 2x10 to whatever you cut it down to. So if I were to cut a 1 inch notch out of this right here, that 2x8 floor joist is now a 2x7. Yeah, keep that in mind, because that's the stressed member, the stressed part. So the fact that they bored holes in the bottom like that, not okay. They should have done it in the middle where it won't affect the load rating at all. But, you know, people do what they do. Well, that's it for now. This is a long ass video, and I think I'm getting tired, so Ori wants to go to bed.